Before we get into adding and subtracting expressions, we're just going to remind ourselves the rules for adding and subtracting regular fractions. So we don't have to worry about these things when we're multiplying and dividing, but if you're going to add fractions, you have to have a common denominator, which just means the denominator has to be exactly the same. So if we look at this first example, we have 3 over 5 plus 1 over 2. 5 and 2 are the denominators. These are not the same right now, so they need to be made the same. What we can do, there's a couple of different strategies. The fastest strategy is always going to be to find the greatest common multiple. So the greatest common multiple is going to be whatever the denominators are multiplied together. So 5 times 2 is 10. That's the greatest common multiple. In this case, it's also the least common multiple, because it's also the first common multiple. First common multiple. Okay, so we're going to multiply this first one by 2, and then this second by 5. So if I create the equivalent fraction of 3 over 5, so that it is over 10, I'm going to have 6 over 10. So 3 over 5 multiplied by 2 becomes 6 over 10. If I create the equivalent fraction of 1/2 so that it's over 10, then I'm going to have 5 over 10. Now that I have the exact same denominator, now I can just go 6 plus 5 over 10 or 11 over 10. And we can leave it as an improper fraction like this. Let's try another one. So we have these denominators here, 2, 3, and 4. So I'm looking for a common multiple that is going to work. So the greatest common multiple is going to be 2 times 3, which is 6, times 4, which is 24. That's the greatest common multiple. Or I can also find a multiple that's not necessarily the greatest common multiple, but another one that I know. So whichever strategy you'd like, both will work. Because I know that 12 also is a common multiple of 2, 3, and 4, I'm going to use 12. To get to 12 from 2, I have to multiply by 6. To get to 12 from 3, I have to multiply by 4. And to get to 12 from 4, I have to multiply by 3. 1/2 over 12 becomes 6/12. 2/3 over 12, like the equivalent fraction of 2/3 over 12, is going to be 8/12. And 1/2 again over 12 is going to be again 6 over 12. Okay, so I've done 2 times 3 is 6, 4 times 3 is 12. So I've just created equivalent fractions so that I have like denominators. Now I can combine these so that it's 1 fraction over 12. I have 6 plus 8 minus 6. That's just going to be 8 over 12. I can reduce this to 4 over 6, and also 2 over 3. All right, one more. Okay, my greatest common multiple is going to be 3 times 5, which is 15, times 2, which is 30. And let's just use that one. Okay. So to get to 30 from 3, I have to multiply this guy by 10. It needs to be 10 times larger. To get to 30 from 5, I need to multiply this one by 6. To get to 30 from 2, I need to multiply this by 15. Okay, 2 times 10 is 20 over 30. 6 times 4 is 24 over 30. And 15 times 5 is 75 over 30. Now that I have my common multiples, I've got 20 plus 24 is 44, minus 75 is 31. Now when we're looking at rational expressions, the same rules are going to apply. The denominators must be exactly the same. So let's look at this first example. 3 over a plus 2/3. A and 3 are not the same denominator. So I'm going to use my strategy of finding the greatest common denominator, greatest common factor, by just multiplying a by 3, which is going to give me a common denominator of 3a. In order to get to 3a from a, I have to multiply this by 3. And 3 times 3 is 9. In order to get to 3a from 3, I have to multiply this by a. And 2 times a is 2a. Now I'm going to write this all as one expression. But a, or 9 and 2a are not like terms, so they still need to be kept in separate here. All right, number 2. I want to add the fractions 1/3 n plus 4 over 2n. 3n and 2n are not the same, so I need to find a common denominator. First, I'm going to find a common denominator of the coefficients of 3 and 2. The common denominator of 3 and 2 is 6. Now I'm going to look to the variables. Right now I have one n and another n. These are exactly the same, so I don't need to actually adjust my variables. To go from 3n to 6n, I have to multiply by 2. To go to 6n from 2n, 2n times 3 will give me 6n. So 1 times 2 is 2, and 4 times 3 is 12. And now I can combine these to be the same. These are like terms, so I can put this to be 14 over 6n. Just like with regular fractions, I might be able to common factor and reduce this. These guys both have a common factor of 2, so I'm gonna just write this out the long way first. I can pull a 2 out of the 14 and a 2 out of the 6. I'm going to reduce that to lowest terms. So the final answer here is just going to be 7 over 3n. All right, number 3. My denominators are 3x and 5x squared. The first thing I'm going to do is look for a common coefficient between 3 and 5. The first common multiple of 3 and 5 is 15. So I'm going to put a 15 in there. Now I'm going to look at my variables. I have an x and an x squared. The first common multiple, if I were counting by x's, would be x squared, because the pattern would go x, x squared, x cubed. So my first common multiple is x squared. All right, to go from 3x to 15x squared, I have to multiply this by 5 and by x. To go to 15x squared from 5x squared, I just have to multiply this by 3. 5 times 4 is 20, and I have 1x. 2 times 3 is 6, and that's it. Now I can write this all as one expression, 20x minus 6 over 15x squared. All right, in this last one, I have no coefficients to worry about, so I'm just looking for common multiples of my variables. So let's look at x first. I have 1x, no x, and 2 x's. So the common multiple is the 2 x's, so that's what needs to go on the bottom. And let's look at the y's. I have 1y, 2y, 2 y's. So the common multiple is 2 y's. So my common denominator is going to be x squared, y squared. In order to get to x squared, y squared from xy, I need to multiply by another x and by another y. In order to get to x squared, y squared from y squared, I need to multiply by x squared. And in order to get from x squared, y squared to x squared, y squared, I don't need to multiply by anything, so that one is good as is. I'm just going to put this one in here now. This should be a subtract 8. Okay, 6x times xy is going to be 6x squared y. 4y times x squared is going to be 4x squared y. By convention, I'm always listing my variables in alphabetical order. This is just a convention rule, and that just helps you see like terms easier, because I could have also written this one here. I could have also written, so 4y times x squared. I could have also written it like this, 4y x squared. So this is not incorrect, but these variables should be written in alphabetical order so that it's easiest to see now that I actually have like terms. This x squared y shows up twice. So I can combine these two like terms. So I'm gonna have 10x squared y minus 8 over x squared y squared. Check for common factors. These do have a 2 in common, but there's no coefficient down here to cancel. This doesn't have any x's or y's, so I can't factor out that, so this is done. Okay, so for a couple rules, just as steps, so step number 1. Step number 1, you're going to find common denominator of the coefficient. That's the number out front. Okay, number 2, then you're going to find the common denominator of the variable. Hint, it will always be the highest exponent. Okay, always will be the highest exponent. After you've done that, you have your common denominators, then you're going to multiply the numerator by the factor necessary. Okay, so whatever you needed to do to get that 3n to be 6n, you have to multiply the top. You have to do the same thing to the top. So whatever you did to the bottom to make that common multiple, you have to do the same thing to the top. After you've done that, you collect like terms. And last step would be to reduce your fraction, which looks like common factoring now, if possible.